Hi, today's notes are on 3.1. This is the first section of Chapter 3. And Chapter 3 is about solving equations, and today we're going to be solving equations by graphing. Before we get started, let's take a look and see what does solving an equation mean. Okay, when we solve an equation, maybe take a moment, see if you can solve for x here. It means get x by itself using inverse operations. So I'll subtract 2 first because that's the furthest away from x. And then now there's this negative 2 in front to get rid of. So I'm going to divide by negative 2 because I want to get rid of that one. I'm just canceling out the things to show that this is why I wanted to get rid of it. Okay. And then if you're careful on your calculator, a negative 2 divided by a negative 2 is positive 1. Now let's take a moment and look at what that means here on this graph. Okay, so this graph is negative 2x plus 2. So this line right here, okay, this is, this function is this graph, okay? So you'll notice that everything is the same except that instead of a y, right, over here we have 0. Okay, so where do we find this answer, x equals 1? Well, if you guys look on the x-axis, right, I'm going to look for 1. And that's right here. And that's at the point 1, 0. Which means my x is 1 and my y is 0. And this is an x-intercept. Okay. So it looks like if we have a 0 here, that 0 tends to show up at the second point. Let's check and see another point. Another equation and see if that's true, right? So let's see if this one comes out to a 4 on our y value. So let's take a look. We're going to solve the same equation. Subtracting 2 on both sides. Okay, we're going to divide by negative 2 next. And we get x equals negative 1 this time. Okay, so let's go look for x equals negative 1 and see if we can find that. Well, x equals negative 1 is here, so I'm going to go up to the line because I do want it to equal to negative 2x plus 2, right? So that's this line. And that point is at negative 1, 4. Okay, so that means I don't actually have to solve this equation. If I knew that this number that we're setting an equation equal is y equals that number, could I say that a faster way to find this would be to draw our line at y equals 0 for this one, for letter A, and then find where it intersects and find the x value, right? And for this one, we can draw a line at y equals 4 across. And I don't even need to solve this. I can find the x value just by looking at the line. Okay. So let's tackle quadratics then. So if you take a look at this function, do we know how to solve 0 equals x squared minus 2x minus 3? Okay. You might have an inclination to add 3 on both sides, but then which x do we solve for? Right? We don't know. So what makes this equation more difficult is that there are 2 x's. How do we solve? Which one do we solve? Or how do we solve for both? I guess that's the question, right? How do we isolate? How do we isolate or get x by itself when there's 2 of them? So what if instead of using solving algebraically, what if I gave you a graph? Could you solve this equation now using this graph, knowing that this is y equals 0 perhaps? Right? So I could draw this line right here. That's y equals 0. And now I can find what the x's are. So that must mean x equals negative 1 and 3. Okay? I don't need to write the ordered pairs, okay, because we're solving an equation and we just want x's. Do you guys see here? There's no like y equals option here, so we just want x's. And what's important to note is that right now, if it's equal to 0, it's an x-intercept. Another thing to notice is that we don't actually want to put this in parentheses because this is x and x. If we put a number in parentheses, this is x and y. Okay, so we don't want this today for solutions. Okay, so now, can we set this y equals -3? Draw our line, right? And we don't actually want that number 3. That's what I want you to be careful of. What we want is the y value, or sorry, the x value when we have y equals -3. So if y equals -3, right here, this one is 2, and this one is 0, -3. So my x values are 0 and 2. So solving by graphing is pretty nice when I give you a graph. Let's take a moment and write out what this means. If I have an equation, k equals f of x, where k is a constant or a whole number, you draw a horizontal line at y equals k. Now, if k confuses you, you could change this to number, hashtag, 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 right? So really what this is saying is you can draw a line at y equals k and find x values of intersecting points. Well, the other thing that we haven't done as much of, because we're so good at drawing it in, is if you have a function y equals f of x, you have two options. You can either set y equals to 0 and draw the horizontal line, or you can just automatically find the x-intercepts. Okay. So let me show you what I mean. Let's actually cross this one out completely. So let's say like I gave you this. And instead of giving you an equation, I just said find the equation or find the solution to this quadratic equation. The solution, if there's no equation, solution equals x-intercepts. Okay? So that means that's these points right here. Okay, what if I do give you an equation? Well, 0 is a nice easy one, so I can just, if I know it's 0, then I know it's down here. And so we have 3. Okay. Now be careful, this one's not equal to 0. Okay, so don't tell me it's like, oh no, I can't find those decimals. This one is at y equals 3. And so if you take a look here, this is called no solution. Please don't tell me it's 0. 0 is a number, but this is no solution. Okay. Remember, if no y value is given, you should always set y equals 0. Can you take a moment and try these 3 as well? Okay, so pause your video here. Okay, so I'm hoping you did this by yourself and you're not just like letting it run, because if I do it all for you, it's not going to go very well, right? So these are just x-intercept because we have y. So we're just going to be -3 and 1. This one is going to be here at 3. It's the wrong function, sorry. And this is going to be, draw a line at -2. And this point, my x is -1. And 3. Okay, so solving by graphing seems pretty easy when you're given a graph, but what if you're not given a graph? Well, if no graph of the function is given, you need to graph the function. And how do we do that? We need to find vertex and use the 1, 3, 5, 7 pattern, multiply by A. If you need a review on this, please go to section 2.2a and 2.2b. These notes are in Canvas modules if you're having a little trouble keeping up. Okay, so you can go watch those again. I'll also go over here. Okay, so example 3, solve this. Well, solve means I need to find the x-intercept, right? Because this is equal to 0. So let's find the vertex, which is positive 4 and positive 4, because this is vertex form. I draw my axis of symmetry. And then our pattern is usually 1, 3, 5, 7 to start, but multiply by -1. Okay, so I'm going to write times -1. That means they just all go down, right? So our new pattern is -1, -3, -5, -7. So from this point, I'm going to go down 1, always go right first, down 3, and down 5. And go left, down 1, left 1, down 3, and left 5. Down 5, left 1. Okay, so let's draw our parabola just to make it more clear. Here's our x-intercepts, which are at 2 and 6. Not too bad? Okay, so this one's a little bit more work. This is not in vertex form, right? So how do we find the vertex? This is in standard form. Well, this is going to take you a little bit more work. So we are going to use the formula x equals -b over 2a. Okay, now here's where you want to be really careful. Okay, so a is, in this case, 1, positive 1. B is positive 6, and C is positive 5. If this was a -6, you would have to write -6 here. Okay, now please, please, please listen to me when I do this. You are always going to have a negative and plug in using parentheses, please. Okay, on the test, there were so many mistakes here. Not because you guys didn't know what to do, careless mistakes. And then there's a 2, and then please use parentheses. Parentheses means multiply. So we're going to have positive 6 in here, and positive 1 down here. Okay, when we multiply that, we get -6 over 2, which is -3. So I'll put that in here for my vertex. Your other number is not 0. Okay, and it's not 5. 5 is the y-intercept. Let's make a note of that. This is our y-intercept. It's not our y value. Okay, it's a y-intercept. This is the y value of our vertex. So in order to find the y value, you have to plug it back in. And we'll put -3 into this equation. Okay, so please you remember to use all your signs. -3 squared, that happened a lot on the test where people forgot the squared, plus 6 times -3 plus 5. -3 times -3, please use your calculator. However, I'm here to also tell you there is a trick. 3 times 3 is 9. Okay, and if A is positive, this first one is always going to be positive. It's never going to become negative. If you tell me it's negative somewhere, calculator, or you messed up. This one is always positive if A is positive, and the next one is always opposite what this sign is. So take a look. 6 times -3 is -18. I don't know if you guys noticed, but the vertex, when you plug in the number, is always double the first number. If you don't believe me, go back and check some other problem. So this is -9 plus 5, which is -4. That's your vertex. My pattern has no multiplier, so it's just 1, 3, 5, 7. A equals 1. right? So we don't have to multiply anything. So let's plot it. -3, -4 is down here. There's a axis of symmetry. 1, 3. There's our y-intercept of 5. That matches. 1, 3, 5. Okay. And so we're looking for our x-intercepts. That means we want -5 and -1. Okay. So try your homework and just remember that if you're given graph only, with no equations, find x-intercepts. Okay. Ooh, there are 3 words I want to throw at you today. They're not super important. They're just another way I can say find x-intercepts. So x-intercepts is the same as solutions, roots, and zeros. Okay, so I'm not going to test you on this very soon, but like if I say find a solution, I'm really telling you to find the x-intercept. If I say find a zero, you still want to find the x-intercept. If I say find the roots, you want to find the x-intercept. Okay, go try your homework. Let me know if you have any questions.